What is the 0.7 rule, and why do detectors need to be spaced at 30 feet? If you ever worked on a fire alarm system, I'm pretty sure you experienced sometime a horn strobe acting funky, or maybe even a strobe device itself not flashing at the end of the circuit. And not having enough power at the end of the line is what can cause some devices to not work on a fire alarm system. So today we're going to learn how to calculate detector space and voltage drop. And this video was inspired by United Ireland 32. I really appreciate this question. So let's get straight into it. So we're going to start with smoke detector spacing, because the spacing will actually determine how many smoke detectors you have to install on a fire alarm system. The amount of devices also may affect how much wire you need, how much current is going to draw, and if you're going to have enough power at the end of the line to make sure every device works on that particular circuit. Now, NFPA 72 gives us a rule of thumb and say smoke detectors are spaced at 30 feet spacing, but the first smoke detector that you install should be 0.7 the spacing of the actual spacing of that detector. I don't want to confuse you. So you just multiply 0.7 times 30, which will give you 21 feet. And usually that's where you will put your first detector. Now, smoke detectors have an average coverage of about 900 square feet. And this is typical to smooth ceilings, flat ceilings with no joist or beams. Now, we know in today's society, we have different types of ceilings, slope ceilings, ceiling joists, beams, all different types of structures when it comes to building out a ceiling. So it is your job to understand how you have to place these smoke detectors within these pockets, or if it's a smooth ceiling at 8 feet, 10 feet, 12 feet, whatever the height and distance is, you need to be able to calculate and adjust how you're going to install these smoke detectors on a floor. So now let's go to this illustration so I can show you a quick demonstration of how you would actually install these smoke detectors on a flat, smooth ceiling. We're going to take an example of a 70 by 60 foot room, and we're going to take the first detector and measure it from the wall 21 feet, and that's where we're going to put our first smoke detector. Our second detector, we're going to measure 30 feet. That will give us 51 feet spacing. So the rest of the wall, we would just minus 70 minus 50. That'll give us 19 feet. We are in range, the length of the room. Even though we have 19 feet, we are still within range. So now we want to deal with the width of the room. We will do the same thing. That first detector, 21 feet. Then that next detector over will also be 30 feet, giving us 51 feet spacing. So in this particular room, that 70 by 60 will give us 4 smoke detectors in this room for 100% complete coverage. As we look at the fire alarm business blueprint, we have 4 out of the 9 modules completed, but you can see here, this is a very robust, a very detailed program. This is something that you're not going to be able to fly by through in 5 minutes. Unfortunately, this is going to take you a lot of time. There's a lot of information in here for you to know. There's more. This is more of a mindset shift versus structural training and things of that nature, because it's going to give you all the tools you need to start your business, to get your fire alarm license, to get insurance, to market your business, to become a personal brand, fix your credit if you already have good credit or bad credit, whatever. It's going to get you a business credit. It's going to give you vendor credit up to $100,000 and more. So whatever you need to actually fully function as a fire alarm company, everything is inside here, the fire alarm business blueprint. So now moving on to heat detectors. Heat detector spacing are 50 feet spacing, but the same rules apply still with the 0.7. So what you would do is multiply 0.7 times 50, which will give you 35 feet. So now let's say if we have a garage or we have a room, mechanical room that's 100 by 100, our first detector we will measure from the wall will be 35 feet. And then we will put the next detector 50 feet after that, giving us 85 feet of spacing. So what we want to, giving us a total of 85 feet spacing, which will leave us of another 15 feet spacing, because we only have 100 feet, the length of the room. So those 2 detectors will cover the length of the room. So we will have to do the same thing now, the width of the room. So it will still be 4 heat detectors in this garage area to fully protect this area if a fire were to ever break out, or if a blaze were to ever break out in this garage area. So now that you have an understanding of how to calculate detectors for heat and smoke detectors, we're going to move on to the NICET circuit, and I'm going to show you how you can calculate voltage drop. Here's the connection that most techs miss in the field. More devices equals more wire equals more current draw equals more power that this circuit has to provide. So if you're in a building doing a retrofit or an upgrade, it may be wise to understand how many devices are on that particular circuit, especially if it's a NAC circuit, before you start adding any more horns or strobes to that particular circuit. You may need to run a new wire or add a booster panel, or if you have a spare NAC circuit, you may want to come off that circuit for the new devices. That's why it's important to understand how to balance your fire alarm system. You want to make sure this system operates when it needs to. Now, voltage drop is fairly simple. It's really just the loss of signal over time, and this can happen through impedance. This is something, not to get all technical, but something that's slowing the signal down to get from one point to the next. That's something that's impeding or slowing down the signal. Next, you could have too many devices on a wire, so that way the power is not able to activate all of the horns and strobes or activate all of the strobes on this particular circuit. So understand that each device has a minimum current draw and a minimum operating voltage that it can actually work on. So it's your job to understand what these devices are and how much power it actually pulls from each circuit. Now, some of the things that can happen to a fire alarm system when your voltage is too low, you may get a trouble on the system saying that you may have a short or open on a NAC circuit. You may just get a power overload. You may get an amplifier trouble. Whatever the case is, definitely it's not going to sound every device on that particular circuit. So whatever the trouble is, you want to make sure that you have enough power to supply whatever device that you have connected on that system. And always just add more power if you need more power. So I'm gonna show you our submittals that we submitted to the MTA for approval. This has our voltage drop. It has all of the details for this fire alarm design, but we're gonna go through the page that's gonna show us the voltage drop. So let's jump straight to it. So here we're looking at a set of submittals that we submitted for approval, which has actually got approved. So on our cover page will be, on any cover page for that matter, be your drawing list, your symbols, scope of work, general notes, wire list, and your sequence of operation. And along the plans, you'll have where you are going to put these fire alarm devices. So as we scroll down and go to the legend where it shows us where we have to put the calculations, but really quickly, this is our one-line diagram that the electricians will use. They'll look at this and say, okay, I got 1 pipe, 2 pipe, 3 pipe, 4. I know what wire goes in this pipe, this pipe, this pipe. So they have a visual of how they're gonna put the system in, high level. But here is where we will outline all of the horns and strobes that are connected to the system, what circuit they're connected to, if we have a booster panel, whatever. So everything will get added on into that configurator, so that way you can spit this out as a report and send it to the engineer, and they could just copy and paste it on a set of drawings like this. So as you see here, we're using a firelight system. This is the requirement that the MTA had spec'd out for this particular site, and we're using a 6 amp power supply. Off the first circuit, it's coming off at 20.4 volts. From point to point, the resistance is about 5.75. Then you multiply that by the actual voltage that is going to be at the end of the circuit. So these are calculations that was all made up inside, not made up, but these are calculations that was drawn up inside the configurator. But if you were to do this by hand, you would want to know the wire size. So we're using number 14 wire. That's first. We're always going to use number 14 wires because we can run it across a longer distance. Now the circuit amp is 0.575. So this is the amperage of the actual circuit, right? The 5.75 is the draw, how much this particular device is going to draw. And this device is set at 115 candelas. So it's pulling a lot of power. At 115 candelas, it's flashing at a very high rate. Now you take 0.88 and you divide that by your draw, your current draw, and you'll get about 1.53 ohms. So as we're looking at this current draw sheet, we'll see that this column here is the draw of the devices that's going to be drawn, because they're all set at 115 candela. So if it's drawing this much power at 115 candela, this is telling me, or telling the system, that we could only put but so many. On each booster, I have 20 devices, and it's spread out between 2 circuits. So on booster panel number 14, because each one of these booster panels have like 6 circuits, this system right here is wild. So each circuit, I put on a first circuit, and on a third circuit, I put 10 of these devices, rather it be the horns and strobes or just the strobes themselves. But inside the configurator, it will give you all of this detail that you would need, and you could just spit out the report and send that over to your engineer for them to put this on the set of drawings. So there's not really an actual person who actually sit down and do this particular math, because we have calculators to do that for you, right? So let me just show you really quick what a calculator look like. So the configurator, this is what the battery calculations will look like, but the configurator will actually spit this information out. So here it shows us the total current draw for this particular fire alarm panel, all of the devices, the input and output devices, rather the data loop. This is everything that's on a data circuit. So this is gonna give us all this information, how much the current draw is for all these devices that we have on this particular system. And then we go to the output side, which are our NAC circuits, because I have a couple of booster panels on this particular job. You will have to put the current load, which is always 1.2, the 0.20 is 20%, and it will spit out the type of batteries you need. But we go above and beyond because the MTA wants to do above and beyond. So we're putting in 18 amp hour batteries with battery cabinets. But you can see here, we have horn strobes, 7 horn strobes on NAC circuit number 5, which is giving us a total draw of 1.41, and then we have some strobes at 115 candela, only 3 of them because we put 10 on this first booster panel, and it's going to also give us this total draw here. On a second circuit, NAC number 6, inside the same booster panel, because we have inside this booster panel there's 5, 6, 7, 8, 9, there's 6 circuits, right? This is a big booster panel. So on this booster panel, I'm only using 3 of the circuits. I'm trying to break up this power evenly on this particular booster panel. So when you're adding these devices inside of the configurator, it'll warn you straight up. You don't have enough power. You have to add power before you can continue. So that's what I found out the hard way. I had to add a whole bunch of power supplies in order for me to add all of the horns and strobes for this particular project. So the third circuit has 12 devices. We have 7 horn strobes and 5 regular strobes, and it's going to give us the total draw. And that's how it consolidated into one report that'll look like this. You would take all those calculations and would consolidate into a report like this, and that's all done through the configurator. So if you have any questions on voltage drop, we could always chop it up in the comments. Now, as a fire alarm company, I just really want you to know, I'm gonna give you some inside scoop. There's not someone sitting there actually doing these calculations. Now, it is good to know how to do these calculations, but as a fire alarm company, when you have a manufacturer behind you, whether it be Edwards, Simplex, whomever your fire alarm manufacturer is, especially Firelight, because it's usually an open source for more fire alarm companies who can't afford to buy the bigger panels. They have a tool that you can use to build out your fire alarm system. So once you get your drawings and you find out what your bill of material is, you use this tool, add your devices, and it'll tell you if you have too much power or if you need to add more power. It'll let you know everything you need to know, and what you do from there is download the report, and then you can send that over to the engineer so they can copy and paste that to the fire alarm drawings. And I did a video on this. I'm gonna put the link in the description so you can see the full video of how you actually write a fire alarm proposal. So that information is in that video, and you can check that out if you want to. If this video helped you understand calculating smoke detector spacing and also voltage drop, I want you to hit that like button. Also share this with another fire alarm tech who may be confused on this same particular topic. I want to help as many fire alarm techs as there is out there nationwide, across the world, wherever you are. I want to get you better at the skill of being a fire alarm technician. So always, if you got questions, chop it up with me in the comments. And if it's a question pertaining to fire alarm, or if you want me to do a video or something like that, let me know, and I'll do my best to put that video together for you. And if you're really serious about NICET training or becoming a better fire alarm technician, join me at the training center where we teach you everything you need to know about fire alarm. You see behind me, I have an EST3X panel. We're gonna be building out a network, so we're gonna be teaching you everything you need to know. Specifically to the Edwards panel, the rules and theories still apply across all fire alarm systems. All right, fire alarm expert out. Peace.